Software's eating the world, but AI's eating that too. Ship, learn, fix, that's how we get AI right. Look at your fucking data, keep that quality tight. Out of the lab, into the field, time to deploy. Real world problems, real solutions, that's what we employ.
Welcome back to How AI is Built. This is Nicolay, and today I'm talking to Paul Iusztin, the author of the LLM Engineer's Handbook and founder at Decoding ML. Paul's career mirrors the of the entire AI field in recent years. He went from implementing CUDA kernels in C++ to building modern LLM applications. And his philosophy is really interesting. Stop overthinking, start building, and let the patterns emerge through iteration. And in this episode, we will be talking about that frameworks are really just training wheels. So they are rather no-code tools that you have to throw away at some point. And also, we will go deeper into his philosophy, like start messy and then refactor once you have an end-to-end process that actually works. So you accept imperfection to accelerate the innovation. And lastly, feel the algorithm. So he thinks you need to build a strong intuition on how AI systems work and how AI works, so you can build something that works well in production. Let's do it.
Yeah.
By the way, how did you get into AI or engineering overall?
Well, actually, since the beginning, I knew I wanted to get into AI. Like, I do AI for almost 8 years or so. I actually have experienced quite a few roles. So actually, I started as a software engineer. I worked 2 years or so, but quite hardcore during my university years. I also tried to found a startup, which failed, of course. But yeah, I was really passionate about software engineering, but I always knew for some reason deep inside that I wanted to get into AI before the LLM vibe and all of this. And yeah, actually, I started with deep learning research. That was like my first exposure to AI. It was quite hardcore. Like my first papers were about 3D object detection with lidars and radars and fusing multiple sensor inputs. Basically, what we do now with multimodal. That was like my first impact on AI, and you had like to write everything from scratch in PyTorch and really low level. And I remember that I had once a task to write like CUDA kernels in C++ and all of that. Like that was my first year in AI, and I had like to read 5 times a paper until it started to make sense. But yeah, I guess it built up a lot of fundamentals right now.
Yeah,
But
I never got into CUDA kernels, but I still remember from like university, the one class, like intro to deep learning we had, where we had to write like most different neural network architectures in NumPy. And in the exam, we had to do the calculations by hand. So like we had to do a few forward passes and backward passes to calculate the weight updates and stuff like that.
yeah, the 4 passes are like reasonable. They're in
Yeah.
the end normal algebra, but yeah, the backward passes are start to get tricky. Yeah.
Nice.
To be honest, I still have like uh issues fully like going through this backward propagation algorithms all the time, but the the good news is that we don't have to anymore, or most of the time you don't have to do that anymore.
Yeah, I think it's good to understand it and like calculate a few simple examples and then basically like in small neural networks, and then
Yeah.
basically you got it and the rest the computer can do. I think I studied a few semesters of math, and this is something you learn. Like you take a few practice problems which are really abstracted down and simplified and extrapolate it out from there. And the really complex case, it's usually
Yeah, like if you get to get the intuition on some simple like dense neural network with 2 3 layers and some neurons. Basically, if you get that, you get the basic intuition. But yeah, I always say that the most important thing is to like have a strong intuition on the algorithm, like to feel it, because when you have to like combine a lot of other algorithms and components into bigger systems and all of that, if you don't, I say feel it, like have a strong intuition that that should come in there, that should be plugged like this, they should work together like this, and just like intuitively to feel that. I think things can get tricky real fast, or you can't innovate. You just copy paste stuff, right?
Yeah. What's a technology or library or something like CUDA kernels you never want to touch again?
Yeah, that's a good question. I guess TensorFlow, like the old TensorFlow, but I that's like I'm happy that most of the code is not written in it. Like I worked once in like the TensorFlow V1. Man, that's that's super annoying to work with, and like that's in my past, and now something more recent, I guess, LangChain. So it's
It's so interesting because the entire space, like in the beginning, everyone liked LangChain because they implemented the stuff so fast, so you actually had a good reference implementation for most of the papers. And at some point, there was just a turning point with everyone starting to shit on LangChain.
yeah, man. Like I like for a simple project on this Philo Agents course I recently released with Miguel. At some point, I just wanted to introduce a simple filter on my semantic search. A simple C filter, nothing fancy, something extremely basic. Like after 2 hours of trying to find my way through the framework, I couldn't do it because they had some restrictions at somewhere down the line and just cut everything through. And I just couldn't introduce a simple filter. And at that moment, I said, "Oh my, I will never use this framework again."
Yep. By the way, I'm curious if you haven't picked tech and AI, what field would you have went into professionally, you think?
Yeah, that's a good question. Like I'm a very analytical person. Uh, I was always fascinated by architecture, like building architecture, but also I saw that I have some affinity over finance. I know it's kind of boring, but like I also manage my portfolio, and I like reading about stocks and the economy and how everything works together, like the geopolitical aspect of it and all of that. I don't know. It's not that interesting, right? Maybe you expected something more like neuroscience or whatever, but I like numbers. So
Yeah, for me, finance is so like I think like finance often is like the domain where applied AI of like or like a new area of AI gets adopted first. So I'm not sure whether you can take finance into like as an alternate career path because it's like most of data science, econometrics got really started in finance.
yeah, and I also believe that maybe not finance, but economic related fields will be really automated a lot by these agents because they're very repetitive tasks and predictable. Maybe not on the stock market and all of that, but other like paperwork related stuff or uh yeah,
Yeah, I think
usually
like
like
yeah, we have a
uh
bunch of projects, insurance and banking, healthcare, like all the document processing stuff,
yeah,
where a large
exactly.
portion is just categorizing documents, categorizing people, extracting information out of certain documents and then categorizing it.
Yeah, and then filling that information in other document and all of that. Yeah, I know that some companies try to do that previously. Like, I know they have a specific name, but I just can't recall it. Companies like UiPath,
Yeah.
which like do process automating, taking information from emails and all of that, filling out the documents. But now with the rise of these LLMs or other related technologies, this can be taken to a whole another level because you don't have to have a specialist that necessarily writes all these workflows. And if some workflow changes, then the whole thing breaks. This can be more adaptable and just related to the structure and like the human part of it.
Yeah. Do you have any like technical hill you would die on? So like a really strong opinion that others heavily disagree with.
Well, actually, I just thought about one today, which is that AI written content is just a natural progression of the field. Because I keep seeing this new trend that AI written content is soulless, and here we die as people. But I see it more as it's a natural transition because of the new technology and just the tool changes. A very similar example is when the internet came up, and maybe artists that were performing like live, person to person, when they transitioned to internet, people, because of the resistance of change, they started to say, if you start performing on the internet, it's soulless. And
Yeah.
it's not. It's just the tools change, the way you you do it change, your brush change to something else, but you're still the same person behind the scenes. And yeah, but yeah, again, I'm like against just throwing into ChatGPT, write me a post about AI. No, that's not what I'm saying. I'm saying just use these tools, and instead of like typing every word yourself, just change the way you work. Instead of writing every character by yourself, just try to create an ecosystem that helps you write faster, create faster, express faster in the end.
Yeah. I think that's like my hypothesis. It's like writing by AI at the moment, like it sucks a lot just
Yeah.
because the writing tools haven't caught up to like where coding tools are. Because in coding, I think like often you have the case where like the next 10 to 15 minutes of coding are very obvious based on the files you are currently working in or have worked on in the past like 10-15 minutes. And I think in writing this would be the case as well, but you don't really have any like AI native writing editors yet, which can pull in all of the relevant context and writing styles. And I can imagine if you take, like, for example, Brandon Sanderson, who wrote like Mistborn and stuff like that, if you take his writing approach and put AI on top of that, I think it would work very well because he tends to have like a very elaborate world building and magic system, which he sets down first and then writes based on that. And I think like if you have all of that stuff in the context window and basically the
Yeah.
character profiles and stuff like that, I think like the writing style of the LLM could be very good.
Yeah, that's I don't know about the guide that you just told me, but that's on what I'm currently working on. So what I have right now is not written by AI because I realize that, as you said, using AI currently sucks, and I don't want to be in that extreme, just use AI blindly and cut down on the value that you send. And I still think that value should come first, and how you provide that value, it's it's not that important in the end. But yeah, I still think that, as you said, that per section, like per section of the article or of the video or whatever, if you provide enough context, and enough guidance, it should work. Like I manually did that for some uh, specific parts of my writing, and it works extremely well. But I think that you need to deep dive a lot into your writing process. Like you need to go a lot on the meta layer of writing to understand like how you think about writing, how you lay down your writing process, how you gather information, if that makes sense.
Yeah, I think writing is way less explicit as code is, because code usually already has style guides which you're following, and
Yeah,
writing, like yourself, you probably don't have a style guide established yet. And if you have, I'm not sure if like it's so well expressed,
yeah, it's
because
super hard.
yeah, it's
it's
really hard to put that on paper. Like, what is my writing style?
yeah. I'm actually working on a style guide, and man, it's super hard. Like, what
Yeah.
do I add there?
Do you,
Yeah, yeah.
you have to read the Economist Style Guide, the news publication out of the UK. They have a really good style guide out there, and for me, that's like the best probably writing, or like the writing I really like to emulate a lot is the Economist writing style, and they have like a 60-page document on their writing style.
Oh, amazing. And you also mentioned earlier another person that's
Brandon Sanderson, the author, yeah.
Brandon Anderson. Okay.
Sanderson. I will send you it later. He's a really good guy on like in general,
Okay,
like
awesome.
fiction writing. What application are you building for your own writing? Is this like a local rack or on top of all your Markdown files?
Uh, yeah, so I actually I just started working on it a few days ago. So actually I'm using LangGraph, but I see it. I don't see it. So I see LangGraph and LangChain as two different ecosystems. I try to use LangGraph without any LangChain dependencies, just use their orchestration system, which to be honest, I like it. Those nodes, how you can really nice visualize them. And they have this really nice way of adding checkpoints and adding human interaction into it. And I like that part, but what's more hard about them is to stay away from the LangChain core and all of that. So you should be quite aware of that, because all their documentation kind of try to guide you to LangChain, back to LangChain. And yeah, to be honest, I don't use agents so far. I don't see the reason to use agents. I try to nail down into some a simple workflow at the beginning, because in the end, at the beginning I want like to put my workflow that I usually have. I try to automate it with some rag on top of it. And I also think that the style guide is really important, and also the research. To be honest, in the beginning, I also want to avoid rag and just introduce a more guided research approach. Like I say,
Yeah.
hey, these are the resources that I want to use in this article or per section, because I know that these are the resources that I would use to get inspiration to write this article or this piece, and just use this. Because if you add rag, it just adds another piece of complexity which you have to maintain, debug, and all of that. Uh, Probably that's like the best way to go in the long run if you want to have like the solution that does everything. But in the beginning, I think it's hard to nail it down, because reg comes with a lot of complexity on top of everything, and I just can put a URL there, scrape it, and the job done.
Yeah. I think rag, it adds another very complex component to evaluate, and
Yeah.
you have to evaluate it on its own and in combination with the other parts of your system. And I think this makes it really complex in the beginning, because you have to like get started setting up two completely independent evaluation data sets, which is just a really hassle. Like, how did you get started in the project? I would love to know, like, what's your process like? How do you start approaching LLM projects when you go from basically you having the idea and now you actually have to start tackling it? What are your first steps?
Well, yeah, that's a great question. I approach LLM projects as I would approach any AI project, except the trading part, which is this big shift that you don't need to do trading anymore. But I say that it's still an AI project because it's a very iterative process. So, for example, what I started initially, I laid down my Python project template to have everything in place, like UV, rough, some linters, and uh, a simple CI and all these very basic pieces, because I think it's healthy to have them in the beginning, because otherwise, if you run some linters over after 1 month of coding, it's living hell to correct all of that. So I like to have, don't overcomplicate it, just the basic stuff there in place. So I have like a nice development ecosystem where it's easy for me to play around and automate this beautification of the code and all of that, let's say. And afterward, I like to have a very naive loop as fast as possible. So I don't focus that much on accuracy, performance, latency, or I don't give a shit about that, to be honest. I just want to have like an end to end process that's working. So I have this input, I have this basic steps, and then output. Basically, I want to focus initially on the interface of the system, right? I think that's super important. And because of that, usually I also focus a lot on the architecture of the system. Like I like to take out like those whiteboards, those free whiteboards where you just lay down how you would like the system to look, what are the main components, what are the interfaces of the system. So basically, you have an understanding of the system that you want to build. But at the same time, I don't like to overthink it, especially if it's like more a small project and not like a corporate level project where it's really important to have like a proposal where everything fits so you don't break anything. So I like to take that approach, but simplify it and don't be that. Take it more like a startup approach. Just get an intuition of what you need to build and just reiterate. And for example, right now I don't have the ideal solution in mind. I don't have like the ideal project structure in mind and all of that. And I don't like to be stopped by that. I just like to for them to like show as they come. Like I just want them to appear by themselves, and they will. But because of that, I consider that I will need to do a refactor at some point, like a big refactor at some point. And that's why usually when I write the code, I like to modularize it really well, like abstract away my main logic from all the frameworks, infrastructure, and all of that, like a very basic clean code architecture, let's say. But again, don't really complicate it, just really basic. Keep your main entities away, keep your main application logic away in simple, in modular classes and functions, which are called from your more infrastructure framework related code. Then as you start developing and having an end-to-end solution, uh, you will start to see that things start to pop up, like patterns in your code start to pop up, and you can really think more deep about it.
Yeah, I
So
think
basically,
these are like the two different approaches. Like enterprise settings, you often like you'll likely have built it before, so you likely know what you have to build. So coming up with like the architecture in advance and then executing on it makes sense. And I think like in a lot of LLM cases, if this isn't really the approach, because you won't know
Yeah.
what works and what steps are necessary. So often like the different components you will need are also not obvious from the beginning.
Yeah, not at all.
Yeah, so you will have to add them over time. So it's always like either you're doing a refactor continuously, where you have like a simple architecture, start from that, and then add on. And at some point, you're basically like on a scooter with like 10 different things bolted on, and then you basically have to refactor it and make it into a bike or whatever.
Yeah,
Like you
you have to keep
continuously.
scavenge like elements along the way and put them on your scooter and transform it into a motorcycle while it it runs.
Yeah, but I think this is the thing that makes LLM so interesting at the moment. The space isn't figured out yet, so it's a lot of experimentation of what actually will work. And
Yeah,
this
yeah. I
like
think no, go ahead.
yeah, and this like on top of the like stochastic nature of AI in general makes it so interesting to work on.
Yeah, totally. Yeah, I think it's like the perfect balance between software engineering and research. Research because, as you said, the path is not yet laid down. You have a lot of things to explore, but it's more software engineering related because it's not like the classic research setup where you have to train some models, evaluate them, beat some benchmarks, and repeat. It's more like around building than finding algorithms.
Yeah, because like I think it's so interesting that the model has been like the model training part is like just completely ripped out of it, and usually you don't touch it that much, or you touch it like at a point in the project where the entire tech stack is so mature, and your project
Yeah.
has evolved so much that it's actually okay. Now it's worth it to squeeze like these extra few percents of
So,
accuracy or performance.
so you're also against fine tuning as much as possible, like
Yeah,
push it as much as possible. Yeah,
yeah.
same here.
I think
I
unless you have been in production for a while, you have a lot of really good training data where the task is really specific, and it's unlikely that other people have the training data as well. And it actually gives you a competitive edge on the market. I would not touch fine tuning.
Yeah, it just adds so much complexity. Like it's crazy how much complexity it's add on top of your everything, starting from software infrastructure
Yeah,
to costs, also like development cycles. I think that's something that many people forget about because
yeah,
if you add fine tuning to create a new feature, is just from one day to 1 week because it's tricky. It's a
yeah.
lot of
That's my biggest
experimentation
pet
over
peeve.
there.
Yeah, it slows down iterations, which are like your bread and butter in any AI application. And like fine tuning, it is like so much effort for a little bang for your buck. How far along do you think are we in like the maturity curve of like generative AI and LLMs?
Yeah, so to be honest, that's really hard, hard to assume. I cannot say like it will be just a bluff. To be honest, I don't have an opinion on this, but I think things start to get there. Like maybe on the LLMs per se side, it's hard. It's really hard to predict because right now I don't see a lot of innovation going on. Just things are we just squeeze more on what we already found out. That this is what happens, but you never know when a new breakthrough comes in, and then we just a new cycle begins basically. So it's really hard to predict on this part. But what I've seen is that we start getting standardization
Yeah.
on how things should get be done, like with MCP, with A2A, and all this. I don't know, movements. Let's say I don't know if they will be stay there or, but I like them, to be honest, because we start getting some ideas on how we should do things, and not necessarily because they tell us what's the way to go it, but I think it will really help in integrating multiple systems. Like my dream or my vision is that we'll have agents as similar to APIs, but instead of like calling basic HTTP uh, HTTP calls, you just plug in a remote agent into your current agent, and they talk with each other, which A2A and similar protocols want to do or already do. But to be honest, I did not have the chance to play with it, and I don't know how well it works.
It works like as well as you can expect it to be. I think I'm so torn on it because I think you're stacking LLM calls on top of each other because you're communicating over the wire, and then basically the A2A server picks it up and actually passes it into the relevant format to do the tool calls. So you have a lot of LLM calls, and the if we at the moment are at like 90% success rate of like formulating tool calls, I think like this would already be like way above the rate we are at the moment. So it would like take a long time to actually get that performance where we need it to be for like enterprise use cases, like 95, 99%.
Yeah.
So I'm not sure whether A2A is the right approach because I'm just chaining two calls instead of just having one. So the failure rate goes exponential.
Oh yeah, yeah, totally. That's why I don't know if this is the right approach, but how I see it is that is more like the API way of doing things. Like the, let's say an SLA of performance, you know, they give you this agent under whatever protocol is out there, and they promise you that 99.99% of time they work, so those error chains don't propagate, right? So you plug in a black box and you have this promise that it will work. But I think that we are really far from that point. But not, this is not like a interface issue, is still an algorithmic issue.
Yeah. Because you mentioned it before, what is like your way or strategy to evaluate the right level of abstraction for a project, like picking between like directly using OpenAI versus using a framework or using like something completely custom?
Yeah, that's a good question. Well, to be honest, I see framework as LangChain and LangGraph, not LangGraph, LangChain, Lemma Index, and all of this really useful for like just to quickly see that something works. You have this quick idea and you want to see in 1 hour, 2 hours that some things work, and you don't want to waste doing anything custom. So using these frameworks are good for that. And afterwards, I will just throw them away, to be honest. I see them as no code or low code tools in the end, that's what they are. So they're not good frameworks to build up on top of. And then for any serious project, to be honest, I will just go straight away in writing your own layer on top of your database, especially on top of your database. So you have to think about how your data will look like in your database, whether it's a vector database, whether you use like a document database, a post like a SQL database or whatever. And yeah, and the next question is, you want to use like these orchestrator tools that all these agentic SDKs to basically orchestrate your agentic logic, or you want to write also that from scratch. I think here is now the tricky part. Like, for example, do you want to delegate all the tooling, how they're called, and all of that to a framework, or you just want to handle that yourself? Uh, do you want to implement the React engine from scratch, or do you want to delegate that to a framework and all these aspects? So now in my mind, we go away from using frameworks that integrate with databases and RAG algorithms, which showed that it's a bad idea, and it's a lot easier actually to just write them from scratch. And we think about abstracting away those agentic patterns like memory tools, all kind of reflection, React patterns, or whatever. For simple projects, I think they're good, but for more complex things where you want to have control, I think it's also healthy to just write your React agent from scratch, reflection agent from scratch, and all of that. Because the reality is that they're not that hard. It's like 1,000. You have a React agent plus reflection in like a 1,000 line of code, give or take.
Which Claude probably one shots.
Yeah.
Does LangGraph also deploy the basically like a microservices infrastructure where each of the different nodes is on like its own microservice, like in its own lambda, or is it just on one big server and you basically pass it along?
Yeah, that's a good question, but I don't think it's like those standard orchestrators. Like you're taking this from the DAG orchestrators where you can put each task on
Yeah.
a different microservice. I don't think it's like that. I think the nodes are just more logical units for you
Yeah.
to do whatever, and they're not deployed. But I'm not one. I'm like 90% sure that this is it, because they offer this service where you can deploy the whole agent as a single unit, from what I've seen, and also the agent is built like a single class. Yeah, I don't think it works like that, but also I don't know if you want to do that, or because I see that land graphs with orchestrators work hand in hand, and I would just delegate this to like framework and metaflows, NML, Prefect, or
Yeah.
whatever you use. You can just call those agents from there and do the infrastructure stuff with those tools.
Yeah. I really like I'm not sure how to call them, temporal restate, deboss, these like durable execution frameworks, because I think these are really built for like the stuff we want to do with agents, or like agents, like longer running workflows where you actually have some assurances that the workflow will be finished and you can restart them at certain points in time. And I'm really surprised actually that they haven't been picked up more by people to actually implement the workflows, because I think they are really well suited for that. What I'm also missing is a little bit, because I think like Cloudflare as an infrastructure provider is really well suited for that, because you don't pay for IO time. So whenever I'm calling an LLM and it turns me back the response for the like wait time, I'm not really paying anything. So I think
Okay.
like the combination of having like Cloudflare workers as like infrastructure plus something like DBoss, which backs up basically each call you make to a function and the output to like a Postgres database. I think the combination of these two could be a really interesting thing for agents and workflows.
Yeah, to be honest, I haven't explored this space at all. But you're saying that orchestrator such as DBoss relative to others like Metaflows and ML, they're a lot more resilient because they offer you this checkpointing mechanism where you can just, hey, I want to rerun this from step 3, or something like that. And they also give you retries, or how are they more different than other orchestrators.
Yeah, exactly. You have always like a database running in the background, and
Okay.
usually they abstract away like the infrastructure the same way Metaflow does, but they add like message queues and state backups as like additional infrastructure components. So the input to a certain function call is basically backed up, and then you determine like basically a retry mechanism, and when it fails you still have these inputs, and this makes it
Okay.
especially interesting if you have like a 10-step workflow in things like LangGraph. I assume at least like when like one step fails you can't retry from that step. In DBOS temporal you can actually,
Okay.
and you also have like a trace of the entire inputs and outputs of the previous steps, so you can actually debug
Okay.
afterward.
So you're suggesting just throw away all these LLM orchestrators and just go directly with these orchestrators.
Yeah. So this is usually what I do. I roll my own logical abstraction, what LangGraph is doing, because I think often you can tailor it more to the use case you're working on. Um, and I have a slightly different abstraction in mind for a lot of LLM use cases as LangGraph has it. And the other case where I'm really going for like I want infrastructure deployment as well. So I'm deploying not on a single node but on multiple. I have like infrastructure components as well. I really like DBOS temporal restate for actually deploying all of the infrastructure and handling this side for me. I think Prefect is doing a lot of interesting stuff around agents as well, but for me, Prefect, it's too heavy. Like there is a pretty big learning curve to actually getting into Prefect, and
Okay.
also it's like you can't really host it yourself that easily.
Yeah, that's the bigger side. Used Prefect with one of my previous clients. And to be honest, I really liked it. It also has this checkpointing mechanism that you said, and all of that. I recall that it had most of it, but the biggest downside is that they kind of try to make you buy their subscription, and to
Yeah,
host them is just a pain in the ass. It's-
yeah,
But it doesn't seem like really hard to pick up. Like for me, Airflow is hard to pick up.
yeah.
It's really hard to pick up. It's super complicated. So you're saying that temporal and debug are even easier than prefect? They're like no brainers.
No, I think like temporal is it's hard. I
Okay.
think temporal I would put it on a level with Prefect. Deboss and restate are way easier and also way easier to self-host. They're like the temporal started the like durable execution, like space technology wave. I'm not sure how to call it. So they were I think like the first comer, but they are already like really established within, especially like the financial space where you're actually handling like transactions.
Okay.
Um, so they are really complex, but you can do like a lot with them. And Restate and Debos are rather like they're really new, and they have like really great DevX.
Amazing. And they're all open source, or there's something like prefect that in the end they want to subscribe to them.
They're open source. I would say like temporal, it's just such a no-brainer to, especially when you get started with it, to actually host it on their solutions. You can self-host it. A bunch of companies we work with do it, but for the start I think it's just way too much work. DBOS and Restate is really doable to self-host.
Okay. Yeah. Yeah, in those open source and closed source gradient, let's say, I think this is the best combo where the solution itself is open source, but they do have a self-hosted solution, so you can just start building right away. But it's nice to know that when things get more serious, you can
Yeah,
you can just take it and take your toys home and do whatever you want with them.
Yeah, I think the offering should not take away from the tool itself, but it should just like make it way cheaper to actually host it, so you can focus on the actual core. And I think in a lot of cases, when you have like a more complex piece of software, this is actually the case, because you wouldn't need multiple engineers to actually manage that stuff.
Yeah. Yeah, the simplest example is Kubernetes. The simplest, the most common example is Kubernetes, not the simplest. The most complicated one is Kubernetes.
Yeah.
Like, almost nobody wants to host their Kubernetes cluster because it's just too much hassle. Even if it's completely open source, or Spark is the same story. It's just you just go to Databricks and that's it.
Yeah. How do you think about, like, we talked a little bit about building new LLM based applications. How do you think about integrating LLMs into existing products? I think because this is a big trend where people try to figure out, okay, what features are the best enhanced with LLMs, and also like how do you actually get started. Like, we have brownfield, we have an existing product. How do I get like something stochastic in a deterministic piece of software?
Yeah, that's a good question. To be honest, I never done this. Usually, all my LM work was usually from ground up. But from what I've seen as a user, I think that one extremely good example is GitHub Copilot and Cursor, right? It basically did just that. It integrated an LLM into a system that already exists. But I see two ways here that would work. The first one is whether you accept that the outputs shouldn't be perfect and let the user take the rest, right? So this we can see with chatbots, writing assistants, coding assistants, or whatever like integrates in our already existing interfaces. Usually they suggest you things, and if you accept them, no. If you accept them, great. If no, you either do it yourself, or they uh, refer you to a human, which how we did things before. But these are more common examples. I think what's more interesting is like what can we automate behind the scenes, like in the backend world of. Uh, but again, uh, I usually the only things that I see that usually get a lot of traction are processing unstructured data, which before was really, I know, based on heuristics, templatized, and all of this. And now we can do this a lot easier. To be honest, I don't know other scenarios that could be. For sure, there are other examples, but I did not have a lot of experience in like taking, I don't know, an existing application and integrate some LLM stuff into it. For example, I know in recommender systems, of course, you could use LLMs, but do we need LLMs in forecasting or whatever? Do we need LLMs in shopping or other normal sites? Do we really need LLMs? So I don't know if we could, but do they make sense?
I don't think so. I think like I'm also getting annoyed by the current area where we're just basically bolting on a chat interface onto existing products. And I hope we get
Yeah.
into like a smarter interface paradigm. But I haven't really seen it yet. I think we are still stuck in the chat era. And
Yeah.
this is also a pet peeve I have with Cursor. It's like Cursor is my daily like code editor of choice at the moment, but I still think like a chat isn't the right way to actually direct it. It's nice to have this flow, but somehow it still takes me out of like the code I'm working on and into like a smaller sidebar. So it's really hard to actually read the code it's suggesting and follow what it's doing. And I think there has to be something like a smarter interface for it.
Yeah. That's why people say that AI nowadays is a UX problem, not a research problem. But Cursor already has like the inline editor when you hit Command
And
K
K, yeah.
and it suggests something. But I feel that that's not that performant usually. What it suggests me when I use that usually is trash. I, I don't like the response, and I always go back to the whole chat thingy.
Yeah, I feel like Command K, I'm not sure whether you can select the model as well. I feel like it defaults to really small models or even a local
Yeah.
one
No,
because
no.
in a lot of
It uses Claude 555.
really,
Like I use it. Yeah,
yeah,
yeah.
because
Like
I feel
it,
like the Command K often like it doesn't follow instructions at all.
yeah, it follows, but usually the code is more trashy. Like I pay for the pro subscription, and only in that option it allows you to use
Yeah,
the command C with any model basically. But yeah, it usually just go off rail.
yeah. Where do you think we're moving next? Like in the entire generative AI space, like what do you think is really on the horizon, which will be like the next high wave or the next breakthroughs which are coming for us?
Well, the end goal ultimately is to apply this technology to robots, right? So that's I think that the current LLMs are just an intermediate point to get there. So that's why having these multi-models system are super interesting, and also applying reinforcement learning to train LLMs is also like a super interesting approach, because in the end, when we'll be able to apply the same technology on the robot, like to have an LLM for the uh, basically the brain that takes input from whatever sensor it has, and it can take decisions. So based on tools of whatever it could have, and also I think that the robot should have like also to learn, right? I think that's the biggest problem right now, because how can an LLM learn without fine tuning necessarily? Or you could do that with reinforcement learning, but is that the simple process of reinforcement learning in my mind is super hard to get right, and you can't put just, I don't know. I cannot see a system on the edge like a robot running on the background reinforcement learning algorithm to update its system, and also only having like the whole thing based on context windows. It also doesn't sound plausible. Like to keep in the context window everything that happens with all your inputs. It's just not feasible to get it right like a human would. So we still have to things a lot of things to crack in my mind to get like to a very smart robot that really adapts in the environment, super dynamic, and learns and remembers what happens and all of that.
I think what's missing for me is like this metacognition, like when to use which type of AI, when to use LLMs, when to use ML, and can we automate this? Like these small training processes of like 100, 200 examples, which we hopefully can capture in the wild and then automatically train and improve a model on. And this isn't just like one big model, or I imagine it won't be one big model, but it will be like an orchestra of like many models working together in tandem, each doing like specialized tasks.
Yeah, it makes sense. You could refer like, so I might be speaking bullshit. I'm not really a biology guy, but you might think about like every small model like a protein, which is specialized in doing some specific thing, and they all support the brain, which can be like the LLM, and all those small models adapt into the environment and whatever they receive. And it's a lot easier, as you said, to adapt these systems than a big fatty guy.
Yeah. How do you try to distinguish between like useful AI developments and new capabilities and between like, okay, that's just hype?
Yeah, to be honest, it's a lot trickier to be done in practice. But usually, what I do, because I'm also like a content creator and I have like to stay in touch with all this hype because of what I do, but in ultimately to not go insane and actually work on meaningful things, I just sit on them. Like for example, on MCP and A2A and all of this, I like reading about them to get a sense of what's going on, but I don't touch them. Like I don't lose my time on all those new things, the latest things that just came 1 month or 2 months ago, because many of them will not be adopted. It is, as you said, it's just hype. It's just a waste of time. So I just sit on them for a couple of months and see what it's still there. So I usually keep like a log of things that I want to learn about, and the things that are still relevant, then I start to dig them if they're still relevant to what I do. Otherwise, like it's just too much going on. You can't keep up with everything. Of course, I do make exceptions to this rule when I work actively on some project and it really makes sense to try a specific thing that will really help me. But otherwise, to try it just for the sake of trying it, in my mind, is a waste of time.
Yeah, I think I was surprised by so many companies actually hopping onto MCP at the state where the project was at that moment in time because it
Yeah.
wasn't even figured out yet. But looking back, because I went into like researching a little bit of HTTP, and when it was first like proposed, it was very raw and like not what
Okay.
it is. And it's just basically it emerged as a standard and was continuously worked on and evolved to be like a really good standard, which it is nowadays. And I think like for MCP, like you set out a very raw bones basic standard and you try to add stuff without like just bolting on bits and pieces.
Yeah, but at the same time, I think it's healthy, like for some people to try it out, because if they're not like super early adopters that try these tools, we never know if they work or what we should add to them. As you said, it was really raw, so if people haven't started using it, we will never know what, if it's useful, what can be improved, what not. So yeah, I don't think it's like you have the framework of how to approach hype. You know, I think you should adopt it on your specific personality, on your specific needs, on how you like to learn. In the end, I like to learn more structured and actually things that I can build with right now, not just to play around with things. So, but people like to tinker. Many people just like to tinker something and they're happy.
Yeah. And if you think like if people want to start building like the stuff you're doing, like with LLMs or like even the newer stuff, what do you think are the best resources out there to get up to speed and just like start doing stuff?
Like staying up to speed in more really hands-on stuff that I
Yeah.
can use these resources and just start coding.
Yeah.
Yeah, that's kind of complicated because I think you should always start with your idea, and based on the idea to find what sticks to it. And to be honest, in this specific agents world, I've seen that the academy that almost all these frameworks provide, they provide a free academy, which is really great. For example, I've did the one for LangGraph really quick, and it's great. Like, they haven't necessarily focused just on the framework, they also focused on agents patterns, hands-on with code. They showed you how to work and all of that. So in my mind, if you go into one of these academies or take a course that's not super complicated, it's the most fast way. But again, I think that you should always start with what you want to build, and based on what you want to build, understand what you need to learn and not the other way around, because many people think that they need to learn a lot when actually when they want to build a specific thing, they don't need to know all of that. Plus that, like, science backs up that if you just learn, you will lose, you will forget a lot of that, right? It's common knowledge, and you usually have want to combine like 20% theory and 80% hands-on stuff. And that's why I think that just start with a project idea and crawl around the internet on whatever makes sense, and like what is the next Lego block in your project makes the most sense. Just use that, read that, apply it immediately, and all of that.
I think I listened to a podcast with the author of Grokking Algorithms a few weeks ago, and I think he really put it like so well. Like, at the moment, like, most of education is like just in case learning. So
Yeah,
you learn
exactly.
for the case that you need it, and not like really like just in time learning that you learn because you need it right now. And I think this is really interesting. Of course, you need a balance of both. You need like some just in case, like your fundamentals, your foundations, all of that. But most of the other stuff should be more like just in time learning and trusting your ability to actually figure it out on the spot, and actually improving your ability to figure stuff out on the spot, like problem solving, debugging, and things like that.
Yeah, totally. And making decisions, I think that's one of the most important skills that you could have, like navigating through all this hype, to all this noise, to everything that you have to do. That's like nobody talks about that, but that's actually so important, that making decisions is just compounds and everything that you do afterwards. And to be honest, based on what you said, a balance between just in time learning and staying on the fundamentals, I'm trying to figure out, like, for me, a system. And I'm like, I think I'm close to it. So I usually have one, two, three projects that I work on. And for that, I do just in time learning. And usually I prioritize that always. But I always like keep not a reading list, but a topic list of big tools or topics that I know I want to learn, and I know they will help me a lot. For example, what I have right now is Ray. I want to get into, like, really deep into Ray, because I know, like, doing distributed compute is a thing that you will need at some point. And I think that I can build some things, or I cannot apply this concept because I don't have like these big uh, tools or knowledge in my tool belt. So usually I try to pick a few big topics that I want to pick. And when I skim LinkedIn on the internet and all of that, if something I see interesting goes into these boxes, I put them there for future learning. If not, I just leave it away, and that's it.
Yeah, the Ray documentation. I over the Christmas break, I read through the documentation from front to back. It's really good. It's probably
The
one of the better ones.
the Ray
I've seen so far.
documentation.
Yeah,
Oh,
it's really
nice.
interesting.
Yeah. I always wanted like to go through Ray and Kubernetes, but not like superficially, like run a simple tutorial, like going deep into the tools and actually understand what's going on.
Yeah, and where can people follow along with you? So, what are the spots where you put out your content?
Well, I'm like weekly present on LinkedIn and my Substack. On my Substack is also like a blog and newsletter. So I write also more long form content over there where I write a lot of code, concept fundamentals, and more like short 2-3 minutes articles. And also on LinkedIn, I post daily over there. And yeah, basically that's it. And you can also, if you're more hardcore, you can follow me on GitHub. I try to write code daily.
That's it for today. Let's quickly talk about our new deal. I'm committed to bringing you detailed and practical insights about AI engineering, development, and implementation. In return, I have two simple requests. First of all, hit subscribe and like right now to help me understand what content resonates with you. And if you found value in this podcast, share it with one other developer or tech professional who's working with AI to help it grow so we can build this podcast together.